So we are going through this paper. This is from Gunning Singh School. Okay, physics final year exam paper, which basically tests everything that you already know. Question number 1. What is your answer? Let's check. Doing C. Wrong. How about what? Yeah. What happened? Because what is the definition of one oscillation? Go there, must come back. See, it's a happy face. Go there, must come back. Okay? Go there, come back. So you didn't multiply by 2, right? That's all. Just need to multiply by 2. Next one, micrometer screw gauge. Whoa. Okay, so we have a zero error, and then you basically need to remove the zero error. Now, what type of zero error is this? Negative zero error. Okay, what is the negative zero error? You need to count backwards. Okay, I know your papers are a bit difficult to see. Yeah? So 1, 2, 3. So negative zero error, negative 0.03. Now, if it's a negative zero error, you need to add to whatever you see over here. Okay, so what's the reading? 0, 1, 2, 2.5 plus this 20. Okay, so it's 2. What's the reading over here? Wait, what do they want? Zero error. Okay, they want to find out what's the zero error. So it's here. Okay, so that's the answer. A. Right? Because the zero error is negative 0.03, as we have seen over here. Then here, you see it shows exactly 2.7. Okay, 2.5, then plus 0.2, so 2.7, then you need to add 0.03, so the actual error is 2.73. Okay, next. Okay, this one should be easy. Elijah, do you get 3? Yeah, that's right. Temperature, this is wrong. Right, it should be Kelvin. Next. This type is like mercy marks. You know what's mercy marks? They give for free. Alright, so you must know. Okay, next. Jovan? C. Which part shows acceleration is decreasing? C is correct. So how can you share with us how do you know that acceleration is decreasing at this point?
It is time graph as S is acceleration.
The what? What is acceleration?
From S is acceleration, T is also acceleration, V is W, there's no acceleration.
They want acceleration decreasing. How do you know this is decreasing?
Because it's slowing down, the speed is very...
The speed is slowing down, man. The speed is increasing.
Yeah, no, as in the high speed.
It's increasing at a decreasing rate. Okay, so what do we do? Speed time graph, the gradient is the acceleration. So you look at the gradient here, quite steep, huh? Then you look at the gradient at V, it's not so steep. So it's decreasing. Very steep, then become not so steep. Do you understand? Gradient of a speed time graph is the acceleration. Next. 2 forces, Elijah, what do you get? 5. C. 5 is D, yeah, answer is D. So how do you calculate net force? Here it's just 1 Newton minus this one minus this one minus this 2, this one minus this is 2, this is 3. So this has the greatest net force to the left. Okay, D. Next. What's the minimum force required to leave out the NP? Given? Leave up P. Leave up here. Moment. A. 6 is A. Yeah, you're right. How do you get this? Find the moment first. What's the clockwise moment? 800 times 3.4. Huh? You don't know? Then how you get guess one?
No, because it's common sense.
Come on. Where? How come? This one, 800 times this one. Do you do any calculation?
I don't know, because I know it can't be about the same amount, except if not, it will be too heavy for conservation.
Okay, very good. So it cannot be 800 for sure. This one looks too heavy. Yeah, very good. This one also too much. So you use agak. But do you know how to calculate?
How do you?
No, let's say if you need to calculate, do you know what to calculate?
No, because I didn't even know what the Facebook was.
You don't even know the what?
It's fine.
The load.
No. It's fine.
Okay, so to calculate this, right, you find the clockwise moment. Clockwise moment is 800 times 0.4. Clockwise moment, 800 times 0.4, which will give you 800 times 0.4, 320. So the here clockwise moment is 320 Newton meter. Now upwards here will be this force times 0.9. So counterclockwise. This one is counterclockwise. CCW. 0.9 times F must be equal to 320. Okay, so F equals to 320 divided by 0.9. So it's 356. Okay, so we can calculate. Okay, accuracy. Yeah, next. Taekwondo practice wooden ball practice. How much force must this take? Yeah. What do you get? Elijah? C. Wrong, man. B. B is correct. So how do we calculate this? Pressure equals to force over area equal FOA. So the pressure is 50,000 Newton meter square. Now this thing must convert to meter. So area is 0.2 times 0.2. Okay, 0.2 times 0.2, 0.04. So A equals 0.04, 50,000 times, just take 50,000 times 0.04. B, 2,000. Okay, to find the force pressure, which is 50,000, is 50K times A. A is 0.04 meter square. Okay, next. What do you get? C, question number 8. Yeah, very good. Okay, need me to go through this? Yeah, you go through. Elijah, do you need me to go through this? No, okay, move on. Next one. What do you get for 9? Elijah? A is wrong. For you? D is wrong. The answer is B. Okay, so let's see how this works. So ball is pushed up by a constant force of 2 Newton onto the top of an inclined plane. There's a friction of 1 Newton going downwards here, right? So now work done against friction. Now, if you're calculating work done against friction, we don't care about the MGH. We don't care about the height. Okay, because friction is opposing motion, and the motion is basically this direction. Okay, so now you see friction is going this direction, and what is the distance? Remember, work done equals what? Yeah, work done equals to force times distance. So our friction here has got a value of 1, and is now I know this thing is moving up, right? But because this thing is moving up, friction is going down against it at a force of 1 Newton over a distance of 13 meter. So it's 1 times 13. Okay, so we get just 13 joules. Okay, friction, force, just take the force times the distance. Even though this thing is moving up, but there is still friction. So the work done against friction is 13 joules. Next. When a piece of ice melting, which of one is true? Okay, what do you get? Well, this looks like chemistry. Elijah? Ice melt. C. The intermolecular force becomes stronger. And wrong Where got move faster? C wrong A. The intermolecular force weaken. Eh? Melt. Okay, and the molecule move faster. The intermolecular force weakens and the molecules move faster. Let's look at the rest. Intermolecular and the speed remains constant. The piece of ice 10 is melting. The intermolecular becomes stronger. Okay, it cannot be this. Weaken is correct. But does the molecule move faster? Then speed of molecule remain constant. Okay, this one is tricky. Wait, the answer says B, but I also want to choose A. When the temperature increases, thermal energy is transferred to molecule gas. Yeah, should be A. Okay, choose A. More kinetic energy because they gain heat energy, so the kinetic energy increases. Next one, pure water freeze. What happens to particle? Sure.
Just go
B, move closer. Yeah, you're right. This kinetic particle theory, right? Physics has this as well. Which substance has the most internal energy? Okay, this is under heat capacity. The answer for this is combination of total kinetic energy and potential energy for the 100 gram of boiling water, 100 gram of ice. Okay, cannot be this. Water, room temperature, 100 gram of steam, 100 gram of steam, boiling water. Let me see. They don't have an answer. So weird. Total kinetic energy and potential in the body for the same mass have the most energy compared to liquid. Okay, so answer is this. Why? Because steam is over here is gaseous state, and then it is definitely more or at 100 degrees Celsius. Okay, so you see this is solid. We don't care about solid. Why? Because the gas, the particles are flying in random, so they got more kinetic energy. Flying everywhere, correct? Boiling water. Now, boiling water, is it still water or is it gas? Yeah, it's in the middle. You understand, right? So it is still a bit of what liquid and gas. So liquid also no you see. So we are looking at gas. Which one has got internal energy means the molecules, the particles. Do they have a lot of kinetic energy, right? Because all of them are at least at 100 degrees Celsius comparing these two. So definitely gas would have more kinetic energy. Okay, which component reduces heat transfer through radiation? Yeah, C. The vacuum. Oh, cannot. Wait, did I go through this with you?
I'm pretty sure I did, but it was.
Forgot. Alright, 3 types of heat transfer, right? Conduction, convection, radiation. Conduction need medium, convection need medium. This one don't need medium. Okay, that means radiation, sun. This is Earth. What's in between the sun and the Earth? Vacuum. So radiation can pass through vacuum. Now, so will having a vacuum reduce heat transfer through radiation? No. So this cannot be the answer because in the outer space is vacuum, no? The heat can still reach Earth. Right? So it can't be this. So the answer is A. The silver color wall. Right? Remember dark color, silver color, the difference? Dark color absorb right? Silver color repel. So the heat gets like repelled. If you're wearing dark color like me, right, during the hot day, it's very hot. If you're wearing like him, you're luminous. You're literally luminous. Okay. So at night, people can see you, right? But can't really see him that well. Why? Because light reflect. Okay, reflect. Any source of light nearby will reflect. You reflect off. Okay, very good for running. Do you wear that for running? At night. Do you run at night? No. You should run at night. Okay. You look like some luminous thing jumping around. Okay, next one. The graph represents the radiation and displacement of transverse wave with distance and time. Which of one describes the wavelength, amplitude, and the period? Alrighty. This is our V equal F lambda thing. Yes, Elijah. That chapter. What do you get for this? 14. A wrong. Hmm? B correct. B is correct. Why? So what is wavelength? Wavelength means one complete wave like that down. So 2 meter. If you put 1 meter is wrong. 1 meter is just half, right? So wavelength definitely 2 meters. So it's either this or this. Amplitude is between here and here. So immediately I got 0.5. No need to see period already, right? It's just 2 and 0.5. Okay, period is 4 seconds. What's the definition of period? Time taken for one wave. So what's the time taken for one wave? Is one wave, 4 seconds. Right, so period is 4. Okay, all right. Next one. Transverse wave velocity. How long does it take? Okay, V equal F to lambda. So I have V equals to 8. What is my what information do I have here? Then yeah, one wavelength. This one wavelength, correct? 1.6. So the answer is D. One wavelength. D. How long does it take the crest to travel from A to B? Wait. I'm not looking for frequency, okay?
Over 3
Hmm?
8 over 3.8.
8 over 3.2. Why?
Yeah.
How long does it take the crest to travel from A to B? A to B. 3.2.
No,
No.
I forgot the card is
No. Wait. Let me read again. How long does it take the crest? Okay, what is the distance here? 3.2 meter. Speed equals distance over time. This is the DST triangle. So time equals distance divided by speed. So 3.2 divided by distance divided by speed. 3.2 divided by 8. 0.4. Okay. Distance divided by speed. Yeah. So this is not V equal F lambda. This is DST triangle. All right. Wrong formula. Next one. What's the distance between him and his image? This is easy. 6. Yeah. Okay. Good. Okay. Refraction. What is the correct order? Forget the 17.
good.
Wrong.
B.
Hmm?
B.
B. Yes. Second chance, right? Outcome. Now look at this. Yeah. From 1 to 2, bend towards normal. So we write down here towards normal. Then from here to here, bend away from normal. Right? Okay, that's the observation. So under what situation does it bend towards normal? This is less dense to more dense. Okay, so between 1 and 2, 1 is less dense, 2 is more dense. So air and glass, okay, makes sense. Then 2 to 3, bend away from normal. Bend away from normal. What does this mean? This is, which one? So this one is less dense again. And then this one is more dense again. Right? So these two, again, it fulfills the criteria because glass is solid, right? Water is liquid. So B, next. What's the refractive index? Oh, what's the formula? Which formula do we use? Let's draw normal. Okay. What do you get for this? Yes. It's either you or him.
I could see.
You put C, Oh yeah. How about you? What do you put? B. You put B, Oh no. What's the formula you use? Huh? Yeah, what formula do you use? You can't remember. Then how tikam, is it?
No,
Huh?
I think I'm familiar with refractive.
Sine I over sine R. Okay? Refractive index is sine I over sine R. The answer is correct, right? But why? It's correct. Why? So where's I? I is between normal and incident ray. This one is
1.54.
correct. So this is I. Now what's the value of I? 90 minus 40, I equals to 50. So sine 50 divided by, now what's R? So R a bit tricky because it's 50. This whole thing is 120. You can minus 90, so here is 30. Okay, here's 90, 120 minus 90, so here is 30. So R equals to 30, sine 30. So we take the calculator, sine 50 divided by sine 30. Sine 50 divided by sine 30. 1.53, so this one, C. Okay, next. You all know this formula, right? Remember? Yeah, so that's why we must do our formula thing again later. Okay? Must memorize. Okay, the physics, right, is very clear cut. You don't know formula, you are dead. Simple as that. Okay? It's like you go to war without your weapon. Sure die one. Sure. I mean, you can run, but there's a 99% chance that you'll die. Okay? Maybe even with your weapon, you get 95% chance that you'll die. Okay, but you get a higher percentage of probability of dying without your weapon. That's it. So must memorize, right? So now it's like we give you the weapon, but you don't know how to use. Like we give you the formula, but you forgot how to use. Oh, die. Okay, this question, converging lens, I don't remember going through with you all. Right, is this converging lens? Did I go through? Lens diagram. This one. Did I go through all this? This one. This is the one. I don't think so. Do you remember your school going through stuff like that? Yeah. So you know how to do? This one. We all the scenario. Elijah have? No. So you have. Okay, it's in your syllabus. Okay, so you need to know, but I haven't gone through because it's a little tedious. Shorter than? I don't know the number, but I'm quite sure I didn't go through because usually I will procrastinate for this chapter. Why? Oh, can you see this? You need to know how to draw. Oh, You must draw. That means, what's the difference between all of this? Now, all of them have got a converging lens. The difference is where is the object. You see the object is here, object here, object here. The distance between the lens and the object. So this one is like super far away, this one is like 2f, this one between f and 2f, this is f, and this is below f. Right, there's actually a simple way. So I'm not going to go through this right now. I'm just going to throw you the answer. Question 19 is B. It's Q. Okay. Now, what is this about? You're supposed to draw and show where is the image. Okay. Now to draw this, the rule is just make sure there are two light rays. One pass through here, then another one must pass through the center. All right. Well, I mean, one must pass through the center. And then another one is focal point. And then go horizontal. Okay. I think my diagram not so good. Top. Top. Okay, what is this? Parallel. Okay. T. Try again. Okay, so you can see that where they converge is here. Can't draw straight. You know why? The thing don't allow me to draw straight. So this is where the image will be. Okay, at point Q. Right, because due to the converging lens and where the how the light rays behave, right, it will be here. Even the one at the top. So I have to draw one line here like this, horizontal. Pass through F, right? You see they will all converge at point Q, like this, right? So there's a way to go through this. I mean, there's a way to draw this. I will show you the next time. Anyway, the answer is Q. Last, which of following has the longest wavelength? This is our grandma X. 20 is C, yeah. Oops. Yeah, that's right. Okay. That is correct. All right, next. Let's move on. Okay. Any questions for MCQ? So, yeah, no have, right? It's like you study a lot of stuff, right? Then only a few come out. That's it. So hopefully that few you know how to do. That's your O level, okay? But the good thing here is they don't have electricity yet, right? So when they merge electricity, that's where it gets a little more exciting, okay? So it's time to try this.